Up until now, we've found the first derivative of several functions. And we saw that there's different notation we can use to write that. We can write it as y prime or f prime of x or dy dx. All of those are representations of the derivative. And if we write it as d dx of f of x, then that's a command that says take the derivative of the function. Sometimes it's necessary to use higher order derivatives. The notation when we do that, for a second derivative, it means take the derivative of the first derivative, and I write that as y double prime or f double prime or d squared y dx squared, which means I have d dx'd the function twice. Third derivative, y triple prime, f triple prime, d cubed y dx cubed, or we are d dxing that function 3 times. Now, there's only so many tick marks I can write. So once we get to the fourth derivative, we write it as y to the fourth in parentheses. Those parentheses tell me it means derivative. Without the parentheses, it would just be a y to the fourth term. F to the fourth in parentheses of x means the fourth derivative. And then our d dx's are just telling us how many times we did it, so they just get regular 4s. And so on and so on. So if we write it as the nth derivative, we'll say that's y to the n in parentheses, or f to the n in parentheses, dny dx to the n, which means I've d dx'd it, or taken the derivative, n times. So let's do some examples. We want to find the derivative of y equals 4x to the fifth minus 2x cubed plus 5x squared, and once we do that, we'll find the derivative of the first derivative to get our second derivative. So this is just a power rule problem. And the first derivative, a 5 comes out front. 5 times 4 is 20, and then I get x to the fourth. A 3 will come out front. 3 times negative 2 is negative 6, and I get x squared. And then a 2 will come out front. I get 5 times 2 is 10, x to the 1. For the second derivative, it again is power rule of the first derivative. So my 4 comes out front. I get 80x cubed. 2 comes out front. I get negative 12x, and the derivative, oops, sorry about that, and the derivative of 10x is 10. Okay, this one is a good bit more complicated. Now, when I look at this, I see there are 2 terms in the denominator being separated by subtraction, so I cannot split this up. I'm going to have to do the quotient rule on it. So my first derivative is low. D high, the derivative of the numerator, is 2x plus 3 minus high. D low would just be 1 all over low squared. So if we multiply this out in the numerator, we will see that I get 2x squared plus 3x minus 8x minus 12. And since this is just a 1 over here, I'm just going to go ahead and distribute the negative. So I get minus x squared and minus 3x all over x minus 4 squared. So I see positive 3x, negative 3x. If I combine 2x squared minus x squared, I just get an x squared minus 8x minus 12 over x minus 4 squared. Okay, so that was our first derivative, so I've rewritten it here, and we want to find the second derivative. Now, in order to do this, when I do d low, I don't know how to find the derivative of this unless I multiply it out. In which case I can power rule it. And I want you to notice something here. Technically, I have something squared in my denominator. That is a single term. This final answer is most likely going to simplify. Okay, so we do low. D high is 2x minus 8 minus high. D low is also 2x minus 8 over low squared. All right, there's a lot of multiplying that needs to go on here in order to get my numerator. And I'm just going to write out the result of the multiplication. It's 2x cubed minus 16x squared plus 32x minus 8x squared plus 64x minus 128. And all of that comes from the first set of multiplications. Then we get minus 2x cubed plus 24x squared minus 40x, and sorry I've run out of room, I'm going to put this minus 96 right here, all over my low squared. And I'm going to combine like terms. My 2x cubes go away. I get negative 16x squared minus 8x squared plus 24x squared. Well, that adds up to 0. And we end up with 56x minus 224 over x squared minus 8x plus 16 squared. Now that certainly doesn't look like anything is going to simplify. Let's factor a 56 out of the numerator, and that leaves me with x minus 4. If I go back from our multiplied out denominator to what we started with, this is actually x minus 4 to the 4th. And so one of those will simplify, and our final answer is actually 56 over x minus 4 cubed. Because this right here was an x minus 4 squared, and then we squared it.